Welcome back. So far in this lecture, we quite focused on proof of work, but there are several other ways of performing a leader election, of choosing who is the one who basically mines a block or selects a block. And I just want to go briefly over them. Some of them are still quite experimental, so we won't go into much detail, but they're still very interesting for you to be aware of. So proof of stake is a leader election mechanism where you vote with your staked assets. So basically you have to provide capital, and this capital allows you to then vote on blocks. It's basically becoming a miner by just putting your money at stake. Delegated proof of stake is something where you allow someone else to vote on your behalf while still staking some of your money. And then a third example is proof of authority, where you basically have a private key and you are the owner of the system, and you say, I prove that I'm the owner of the system. So it's a centralized system. There might be some use cases where it's interesting to use such a centralized system structure. Now, what's the idea of proof of stake? Well, the idea is that validators commit some stake, and then those validators, they can propose, and they can also attest blocks from other block proposals. So the block proposer is selected randomly. So we need some form of a random selection process to perform this. And once a sufficient number of validators attest the block, this block is considered valid. So we need some kind of a threshold here, or agreement of how much is enough. It's quite unclear. Block rewards that are then paid for proposing a block, as well as for the attestation of a block, ideally. And what we also want in such a proof of stake system is that there are penalties for malicious behavior. So for example, if the proposers are being selected but they're currently offline and they're not reacting, well, that's bad, right? Because the chain doesn't grow. It's basically slowed down. So they need to be punished to some degree. Now, if a miner attempts to fork the chain or attempts to propose a block that contains invalid data, then they should be punished significantly by, for example, removing their stake. This is what the community sometimes refers to as slashing stake. So it's certainly a nice idea, this proof of stake, but it's quite complex. It's much more complex than proof of work. There's various efforts ongoing to build such systems. I think we should be quite curious to see how they pan out. It's not yet clear how the full details of these systems will be and what are the security properties, how they're comparable to proof of work. But it's certainly something to have an eye on. I would like to conclude this lecture. I would still like to discuss two myths that are basically floating around proof of stake. So many people think that proof of stake itself increases scalability, and that's not the case. Proof of stake is really just a leader election mechanism, but it doesn't increase the throughput of a blockchain. So maybe if proof of stake is combined with sharding being that you basically create like multiple partitions where you reach consensus, and then later you reach consensus first within each partition, and then later you communicate cross shard. Maybe this does help in the throughput of these blockchains. But this also introduces quite a lot of overhead, because you have to have cross-shard communication, which is an overhead. Not impossible, but an overhead. So proof of stake reduces centralization. This is something I hear quite often, and it might be, but I haven't seen yet any work quantifying if that is true. So I mean, if I look at, for example, the global pyramid of wealth, right, you can see here that about 70% of the population, right, has less than $10,000 at their disposal, right? While the majority of the funds are owned by only 0.7% of the individuals, right? So 0.7% of the world population have more than $1 million. And if you basically extrapolate this to a proof of stake system, then a proof of stake system would probably be quite centralized as well, just because of the global pyramid of wealth distribution. Moreover, validators will probably not want to operate a professional grade server at their home. So what they will do, they will work with staking companies, and the staking companies will do the staking for them, and then we're back to mining pools. So I'm happy to get feedback from the community about whether proof of stake really reduces centralization or not. I haven't yet seen any academic or quantitative work that quantifies this claim. Very nice. Thank you for watching.